So like I said, lots of review. I bet you could tell me a lot of what's on this page right now. We are doing real numbers, which is a majority of what we will be working with in Algebra 1, okay? The opposite of a real number is an imaginary number, and when we get to Chapter 4, we'll work in that realm, okay? Imaginaries, but for now, these are real numbers, and we're gonna separate the real numbers into two different categories. Anyone think they know what those two categories are? I'll be really impressed. One starts with an R and one starts with an I. Do it.
Rational.
There it is. Ooh, we're a little choppy. Hold on. So rational, okay, and irrational are the two types of numbers that we're going to focus on today. A real number, which is all of these, right? Real or rational and irrational, they can all be put on a number line. So if I have a number line, 0, 1, 2, 3, -1, -2, -3, right? I can put rational numbers and irrational numbers on that number line, okay? Imaginaries, you can't. So just keep that in mind. Real numbers is like your umbrella that we're working under right now, right? Everything we talk about right now is a real number. And the way we represent real numbers in like shorthand is that it kind of looks like that paragraph symbol, right? It's the 2 bars down, but it's an R instead of a P. That's real numbers, okay? Then we have rational numbers versus irrational numbers, okay? The rational numbers, is this what your notes look like? It's not what my notes look like. What happened? Shoot. Sorry. My notes that I was trying to give you are much nicer than this because I filled in most of this. Okay, you're just going to have to write a little more. Rational numbers can be written as a fraction. I wonder what I did here. Okay, it can be written as a fraction. So like A over B is a rational number, okay? A terminating decimal. Do you know what terminating means? Terminating means it does have an end, right? It terminates, it ends. So a terminating decimal, that would be like 2.75, okay, is a terminating decimal. It has an end, whereas like 1.237468, not a terminating decimal. Can anyone think of a number that's not a terminating decimal? A very popular number? You wanted to say it right there. I saw it. Pi, right? That's a non-terminating decimal. So terminating decimal, 2.75, or a repeating decimal. Okay, a repeating decimal would be like 2.666, or we write it as 2.6 repeating, right? That's what that little bar means. So that's the rational numbers. The repeating decimal works because you can write it as a fraction, right? 0.6 repeating is 2/3. So 2 2/3, that's a fraction. So the rational numbers, if you want to represent that with a letter, like the real numbers, we use, who said it? Somebody? No? Anyone know the letter? It's a Q. Can't use R, right? Because we already used R for real numbers. So rational is a Q. All right, natural numbers. So this is, all the rational numbers are natural, whole, and integers. What are the natural numbers? Anyone know? If I were naturally going to count to 10, where would I start? At 1, right? If I said count to 10, most people are going to go 1, 2, 3, right? So this is the counting numbers. So 1, 2, 3, and so on and so forth. Okay, those are natural numbers. And the way we represent natural is an N. Okay, then we have whole numbers. Anyone know what the whole numbers are? I always tell people this is their clue. Where do whole numbers start? At 0. So it's the natural numbers with 0. So that would be 0, 1, 2, 3, and so on and so forth. Okay. So it's the counting numbers and 0. Whole numbers, it's a W, which is nice. Then we have integers. Anyone know what letter is represented for integers? Have you ever learned that? This one's funky. It's a Z. Because I is irrational, which we're going to get to. So integers is Z. Anyone know what the integers are? -2, -1, 0, 1, and 2 in both directions, okay? Not a decimal. So it's the whole numbers with their opposites, okay? Whole numbers and their opposites. Okay, so everything we just talked about is a rational number, right? They could all be written as a fraction. How would you write 2 as a fraction? 2 over 1, right? Anything over 1 is that number. Okay, the other category then is the irrational numbers. Can anyone tell me an irrational number that you know of? We've talked about it already this morning. Pi is an irrational number, right? So an irrational number is decimals that don't terminate or repeat and can't be written as a fraction. Okay, so that would be like, well, first of all, this is an I for irrational. That would be pi. Can anyone think of another one? They're less commonly used, so maybe you don't have it in mind. How about the square root of 2? Right? If you plug the square root of 2 into your calculator, you get this really long number that just goes on and on and on. Okay? So that's an irrational number. All right, so only thing I'm going to ask you now are these questions. School has a cross-country team. Which set of numbers does not contain the number of people P who are on the team? There's natural, there's integers, there's rational, and there's irrational. If we're talking about a number of people, integers would have it though, right? Because you can have like 17 is an integer. You can have 17 people on a team. Which one can't represent a number of people? Irrational, right? You can't have the square root of 2. You can't have a decimal, and irrational numbers will always be represented with decimals. So irrational will be that one. Okay. Example 2, if each person on the team had to pay $175.50 as a team fee, circle the one set of number that best describes the situation. Okay, the best set of numbers. There's multiple here, potentially, that could work. Okay, what's the best set? Now, everything we talk about is a real number, right? So we know the answer here is real, but that's not the best answer. What's the best answer for this? Rational, right? It's a decimal. It's a terminating decimal, 175.50. So rational would be the best. It's not a whole number. It's got a decimal. It's not a natural number. You can't count to that number nicely. And it's not an integer. Okay, so rational would be your best. Circle the one set of numbers that best describes the area of a circle. Ooh, geometry. I don't remember the formula for the area of a circle. A equals pi r squared, right? What's the best description of the area of a circle then? What's the best description? Irrational. There's pi in there, right? Now you could round it, and then it would be rational if you rounded, but because we're saying pi times something, that is irrational. Okay? Last one, circle the one set of numbers that best describes the number of students in my classroom. Now, you could argue that this could be different options. We'll see what your rationale is for why you pick the one you pick, because I would technically take a couple answers here, I think. Well, no, there is a best answer, but I understand another answer. What would you pick here? I'm saying the number of students, oh, here. Okay, if I'm saying the current number of students in my classroom, what's the best answer? What would that be? Natural. Yeah. If I were to say, what is the best answer for the potential, right? The number of students that could be in my classroom. Whole, because I could have 0 students in my room, right? I can't have a negative number of students in my room, so it's not going to be integers, but I could have 0. So your best answer here for the number of students that could be in my classroom would be whole. I could have 0, but I could have 1 or 2 or 3. I'm not going to have a half of a student. I guess if you stood in the doorway, we want to be real technical. But, so the numbers, all the real types of numbers. Any questions on that?